Hi, welcome to the video of Trigonometric Functions Part 1. In this video, we will study about the 6 trigonometric functions and its important properties. At the end of this video, you will be able to identify 6 trigonometric functions. So, let's start introducing the 6 trigonometric functions with the help of this diagram. So, this is what a 1/4 circular part of the circle is considered here, whose center is origin and we mark it as O and its radius is R. Now, let the circle cuts the x-axis at A and on the y-axis it is cutting at B. And P with the coordinates x and y, it is a point on the circle. Now, what we are going to do is, we will join this point P with the center of the circle and we got OP. So, OP is nothing but our distance R, which is the radius of the circle. And we will draw a line perpendicular from P to the x-axis and that is going to be our PM. So, M is cutting the x-axis on the point OA on the point M. So, we got OP is equals to R, OM is equals to X and MP is equals to Y and angle XOP is equals to theta. And this triangle is actually a right angle triangle because PM is perpendicular to OA. So, angle OMA is our 90 degrees. So, now keeping this figure in the mind, we will define the 6 trigonometric functions. So, first function is the sine theta. Sine theta is defined as perpendicular by hypotenuse. So, if you look at the diagram, the perpendicular is the distance from P to M. So, distance from P to M, we label it as y. So, that is why it is written y. And the hypotenuse is the distance from O to P in that right angle triangle. So, the O to P distance is defined as R. So, this is y by R. Similarly, cos theta is defined as base by hypotenuse. So, again refer to that right angle triangle. In that right angle triangle, OM is the base of that right angle triangle and the distance from O to M is the value x. So, it is written x there. Hypotenuse is the same, it is distance from O to P. So, its value is R. So, this is x by R. Now, cosecant theta. Cosecant theta is equals to 1 by sine theta. So, what is 1 by sine theta? From the definition, you can say that it is hypotenuse divided by perpendicular. So, this is R by Y. Similarly, secant theta. Secant theta is 1 divided by cos theta. Since cos theta is base by hypotenuse, so 1 divided by cos theta is equals to hypotenuse divided by base. So, in this case, secant theta is equals to R by Y. Now, tan theta, it is defined as sin theta divided by cos theta. So, which is equals to perpendicular by base. So, perpendicular is your y, base is your x, provided that the x should not be equals to 0. Why? Because if x is equals to 0, this ratio is not defined. So, in every case, we used to consider that x is not equals to 0. So, from the figure, tan theta is equals to y by x. And cot theta is actually cos theta divided by sin theta. So, this is base by perpendicular. So, base is again your value x, perpendicular is your value y. Again, we are mentioning the condition here that y should not be equals to 0. Why? Because if y is equals to 0, this ratio doesn't make any sense. So, if y is not equals to 0, cot theta is defined as x by y. So, knowing all these 6 trigonometric functions, let's try to make use of the figure and find the value of R. So, we know that in the right angle triangle PMO centered at the point M, right angle at the point M, R is the hypotenuse of that right angle triangle, X and Y are the two sides of the right angle triangle. So, you can remember the Pythagoras Theorem which says that square of hypotenuse is equals to the sum of other two sides. So, this is what it is written, R square is equals to X square plus Y square. So, how to get the value of R? Taking square root of both sides. So, for the left hand side, R square and the square root, it get cancelled and you are left only with R. Moving to the right hand side, the value comes out to be plus minus under root of x square plus y square. But since we are interested in taking only the positive values, so that is why we have written r is equals to plus under root x square plus y square. We are neglecting the negative values of under root x square plus y square. So now sin theta was defined in the earlier slide that it is y by r. So now we have the value r is equals to under root x square plus y square. So substituting that value here, we got y divided by under root x square plus y square. So if in a right angle triangle we know the two sides of the right angle triangle, that is we know the values of x and y, we can calculate sin theta from there. Similar is the case with your cos theta. Cos theta defined was x divided by r. So replacing the value of r by under root x square plus y square, it comes out to be x divided by under root of x square plus y square. Tan theta, it doesn't contains any value r, so it is as it is y by x provided x is not equals to 0. Cot theta is x by y provided y is not equals to 0. But in the secant theta, it was the reciprocal of the cos theta. So here this is under root x square plus y square divided by x, and the cosecant theta, it was a reciprocal of the sin theta. So this is equals to under root x square plus y square divided by y, with the condition that these values of x and y should not be equals to 0. And if it is going to be 0, this ratio is not defined. So it should always be there that the denominator should not be equals to 0. So knowing all these 6 trigonometric functions, let's study some important relationship between these 6 trigonometric functions. So first relationship says, if you are going to take the ratio of sin theta and cosecant theta, it is going to be 1. How? You know that sin theta is your perpendicular by hypotenuse, so this is y by r. Cosec theta is hypotenuse divided by perpendicular. Put it there, do the calculation part, it comes out to be 1. This means that sin theta divided by cos theta, this ratio is equals to 1. So if the ratio is equals to 1, this means that they are reciprocal to each other. That is, sin theta is a reciprocal of cosecant theta and cosecant theta is a reciprocal of sin theta. You can say it in either of the way. Similarly, you can define the relationship between cos theta and sec theta. Cos theta and sec theta, they are reciprocals of each other. So cos theta is equals to reciprocal of sec theta, or sec theta is a reciprocal of cos theta. Similar type of relationship holds in between tan theta and cot theta. Both are reciprocals to each other. So you can say that tan theta is equals to 1 by cot theta, or cot theta is equals to 1 by tan theta. Now let us look at the relationship between sin theta, cos theta and tan theta. So if you are going to divide sin theta by cos theta, so as defined, sin theta is your perpendicular by hypotenuse and cos theta is equals to base by hypotenuse. Put the values there. So it comes out to be y by r whole divided by x by r. On simplification, it comes out to be y by x. Y by x means it is perpendicular by base. Do you remember the definition of tan theta? It says that tan theta is nothing but it's a perpendicular divided by base of that right angle triangle. So this is exactly the tan theta. So the relationship between sin theta, cos theta and tan theta is that tan theta is equals to sin theta divided by cos theta. Also, cot theta is the reciprocal of tan theta. So from here we can define that cot theta in terms of sin and cos, it is cos theta divided by sin theta. Now let's try to understand these 3 important identities. They are very important because in the problem solving you are always going to make use of all these identities to make the equations in a simplified form. So first statement says that sin square theta plus cos square theta, it is always equals to 1. The second one is 1 plus tan square theta is equals to secant square theta. And the third says 1 plus cot square theta is equals to cosecant square theta. So let's see all these one by one. So look at this figure. So here in the figure, the r is the hypotenuse of the right angle triangle, right angle at M. So r square is equals to x square plus y square by making use of Pythagoras theorem. Now we will divide this equation throughout by r square. So it comes out to be x square by r square plus y square by r square. This is equals to 1 because r square by r square anyhow comes out to be 1. So we can write this expression as x by r whole square plus y by r whole square is equals to 1. But what is x by r? X by r is nothing but the cos theta. And what is y by r? Look at the figure, you can easily find it out. Y by r is the perpendicular by hypotenuse, which is nothing but your sin theta. Put these values of sin and cos in this expression, we got cos square theta plus sin square theta is equals to 1. This is what we want to prove. Now let's start proving this identity. 1 plus tan square theta is equals to secant square theta. So for this again we will make use of this expression that r square is equals to x square plus y square. Now we will consider the case because x is not equals to 0 in this right angle triangle. So what we will do this time is we will divide this expression throughout by x square. So look at the left hand side. When we are going to divide each and every terms on the left hand side by x square, the first term will be 1. Because x square divided by x square, it comes out to be 1. So that is why 1 is there. Plus the second term is your y square divided by x square. So it is written as it is. Moving to the right hand side, this is equals to r square divided by x square. So again it is written as it is. Now we can make a little bit simplifications. We can write this exact expression in the form 1 plus y by x whole square. This is equals to r by x whole square. But again what is y by x? Y by x is nothing but your tan theta and r by x is nothing but your secant theta. So substitute the values there and we got the result that 1 plus tan square theta is equals to secant square theta. Now let's move to the third identity, which is 1 plus cot square theta is equals to cosecant square theta. Let's try to prove that also. Again making use of the Pythagoras theorem for the right angle triangle, saying that r square is equals to sum of other two sides, which is equals to x square plus y square. In this case, we are going to divide whole expression with y square with the meaning that y is not equals to 0. So on dividing this expression throughout by y square, looking at the left hand side, the first term comes out to be x square divided by y square. And for the second term, it is y square divided by y square. So this comes out to be 1. So on the left hand side, we got x square by y square plus 1. And to the right hand side, this is r square by y square. We can rewrite this expression in the form x by y whole square plus 1. This is equals to r by y whole square. But now, what is the value of x by y? It is nothing but cot theta. And what is the value of r by y? Just rewind the definitions in your mind. It is nothing but cosecant theta. So put these values in the expression. We got cot theta whole square plus 1 is equals to cosecant theta whole square. We can write this as cot square theta plus 1 is equals to secant square theta. So this is what exactly we want to prove in our third identity. In this video, you learned the 6 trigonometric functions of angle, which are sin theta is perpendicular by hypotenuse, cos theta is equals to base by hypotenuse, secant theta is equals to 1 divided by cos theta is equals to hypotenuse divided by base, cosecant theta is equals to 1 by sin theta is equals to hypotenuse divided by perpendicular, tan theta is equals to perpendicular by base, and cot theta is equals to base by perpendicular. Trigonometric function has its importance in almost every physical sphere. It is important in the study of triangles and modeling periodic phenomena. Among many other applications, it can be used in the study of wave functions.